Good morning, dear student. In this lecture, we discuss the prediction of spinel structure, either it is normal spinel or inverse spinel. For predicting the structure of the spinel, uh, we consider the two important points. That is, we find out the CFSE crystal field stabilization energy in octahedral field as well as in octahedral and tetrahedral field. That is, we find out the crystal field stabilization energy in octahedral and tetrahedral environment, octahedral and tetrahedral field for both A plus 2 ion and B plus 3 ion, both A plus 2 and B plus 3 ion. The important point is that if CFSE for B plus 3 in octahedral, if CFSE for B plus 3 ion in octahedral environment is greater than CFSE crystal field stabilization energy for A plus 2 in tetrahedral environment, then the spinel is normal spinel. So you should keep in mind, that is, whenever the crystal field stabilization energy for B plus 3 ions in octahedral environment is greater than the crystal field stabilization energy for A plus 2 ion in tetrahedral environment, then the spinel will be a normal spinel. The third important point is that if CFSE for A plus 2 ions, if CFSE for A plus 2 ion in octahedral environment, if CFSE for A plus 2 ions, that is, if CFSE for B plus 3 ions in octahedral environment is greater than CFSE for A plus 2 ion in tetrahedral, then it is normal spinel. If CFSE for A plus 2 ion in octahedral environment, if CFSE for A plus 2 ion in octahedral environment is greater than CFSE of B plus 3 ion in tetrahedral environment, then the spinel is inverse spinel. Then the spinel is inverse spinel. So you should keep in mind. So you should only consider this point. That is, if CFSE for B plus 3 ion in octahedral is greater than CFSE for A plus 2 ions in tetrahedral, then it is normal spinel. If it is not, then it is inverse spinel. So no need to keep in mind the third point, that is, if CFSE for A plus 2 ions in octahedral is greater than CFSE of B plus 3 ion in tetrahedral. So let us discuss the first example for prediction of this spinel structure. So with regardless of the sign, so we are not considering the sign, that is, either it is positive value or negative value. So which is the large value, we can discuss it. So let us discuss the first one, that is your Mn3O4. So we know Mn, one Mn is plus 2 oxidation state, another 2Mn, it is in plus 3 oxidation state, and there is a O4 is there. So we know that Mn second, when Mn in plus 2 oxidation state, then it is 3d5 configuration, and it is 3d5 4s to 3d5. So we consider only d electrons. So 4s to 3d5, so it contain only 5 electrons. So it having a configuration T2G3 and EG2. Similarly, if you consider the Mn third, that is Mn in plus 3 oxidation state, then it is 3d4. So 4s to 3d5, but it is in plus 3 oxidation state, therefore its valence configuration is 4s0 3d4. So it having T2G it having T2G third Eg1 configuration in octahedral environment, in octahedral field or environment. Similarly, we can write Mn, it is in plus 2, it having configuration that is 3d5, it having a configuration that is E2 T2 3. Similarly, when Mn it is in third, then it having 3d4 configuration, then it having E2, and then T2 is there. It is in tetrahedral field or tetrahedral environment. Tetrahedral environment. So at least you should know this. And then we find out the crystal field stabilization energy. So we know the formula for find out the crystal field stabilization energy, that is crystal field stabilization energy. So we know the very well the CFAC for Mn second. So we find out this for octahedral case. So we find out this CFAC for octahedral, that is CFAC for Mn2 plus in octahedral, which is equal to, so this is having formula, that is minus zero point 0.4 into number of electrons in T2G, that is 3, plus 0.6 into number of electrons in Eg, that is 2, into delta octahedron, so it becomes 0. And similarly, the CFAC for Mn third, which is equal to minus 0.4 into number of electrons in T2G, that is third, plus 0.6 into number of electrons in Eg is 1 into delta octahedron, so it becomes minus 0.6 delta octahedron. Similarly, we can find out for tetrahedral. For tetrahedral, so CFAC for Mn second, which is equal to minus 0.27 multiplied by 2, that is number of electrons in E orbitals, plus 0.18 into number of electrons in T2, that is 3 into delta octahedrons, so it becomes 0. And similarly, CFAC for Mn third in tetrahedron, it becomes minus 0.27 into 2 plus 0.18 into 2 into delta octahedron, so it becomes minus 0.18 delta octahedron. So let us compare all this value, that is CFAC for Mn second in octahedral is 0, for Mn third it is minus 0.6 delta octahedron in octahedral field, and in second for tetrahedral field, the Mn second CFAC is 0, and Mn third the CFAC is minus 0.18 volt. So we know that. So in this case, we discuss the first one, that is if CFAC for B plus 3 ions, so where is B plus 3, that is your Mn third. If CFAC of B plus 3 ions in octahedral field, so this is your octahedral field, so CFAC of B plus 3 ion in octahedral field is greater than CFAC for A plus 2 ion in tetrahedral field. So CFAC for A plus 2 ions in tetrahedral field is what, 0. So regardless of sign, so in this case the B plus 3, so this is your B plus 3 in octahedral is greater than A plus 2 in tetrahedral. So this is the case because we know that B plus 3 in octahedral environment, the crystal field stabilization energy for B plus 3 in octahedral environment is 0.6. No doubt it is negative, but we cannot, in this case we can't consider the sign, so the value is 0.6 for B plus 3 ion in octahedral. And if you consider the CFAC for M plus 2, that is A plus 2 or Mn second, then it is 0. So 0.6 is greater than 0, and therefore the first case, that is if CFAC for B plus 3 ion is in octahedral environment is greater than CFAC for A plus 2 ion in tetrahedral environment, then it is a normal spinel. Then it is a normal spinel. So this structure, that is your Mn3O4, it is normal spinel, because the crystal field stabilization energy for Mn third, that is B plus 3 ion in octahedral field, is greater than the crystal field stabilization energy for E plus 2 ion in tetrahedral environment, and therefore it is a normal spinel. So this is your this is Mn3O4, it is your normal spinel. It is your normal spinel. Similarly, we can find out the different spinel, either it is normal or inverse depending on the crystal field stabilization energy. So this is all about the prediction of the spinel structure, either it is normal spinel or inverse spinel. So you should keep in mind, whenever there is a Fe metal atom is present, then there is 100% chances that the spinel is inverse spinel. Many times the question is asked in CSIR NET and SET exam on this spinel, prediction of spinel structures. So you should keep in mind what is normal spinel, what is inverse spinel, and how one can predict structure of this normal spinel and inverse spinel. So in the next lecture we will discuss the remaining points regarding to these ferrites. Thank you.